Okay, so now we're going to discuss. Today we're going to discuss inequalities in two triangles. Now this lesson is shortened, so you should have plenty of time to get your homework done tonight as well. All right, so it says your I can statement. Compare a pair of sides of two triangles when the remaining pairs of sides are congruent. All right, so let's take a look at. We're not gonna do the reason and explore. We are going to take a look at example 1. It says, as a rider pedals a unicycle, how do the measures of angle A and length B change? What does this suggest about the change in the triangle? Oh, we are on 128. All right, so take a look at this. Here is our first seat. So here's this unicycle. Originally, we have this crank arm right here, and here's our angle. There's angle A, there's the length. As the unicycle wheel turns, you guys can see that angle A is getting wider. And as angle A gets wider, side B also increases. So if two sides of a triangle stay the same, but the measure of the angle between them increases, the length of the third side also increases. This is the whole idea. All right, you're going to want to write that down, probably in the blue part. All right, so you see how A has a fixed position, between the seat and angle A, we have this fixed position, right? And this length, or this length right here between, that kind of turns that pedal, stays the same because it's a radius. But B, as angle A increases, side B increases with it. Does that make sense? So if you have two parts that are congruent, but then it can open and close or change based off of, circumstances, then that third side has to increase with that length, with that angle length. So you're going to want to write this part down, put it in blue. Show of hands who's still writing this down. Okay. Just the bottom part. We're not doing two. Oh, you're talking about that. Never mind. You are doing that. Just ignore me. Yes. Show of hands who's still writing this part. Okay, another minute.
No, it's as what I did, but it was I don't even remember this. Every time we sleep over, it's always a good compilation. Yeah, we've got other 3 times. No, but they're so. No, it's been more. I did it once at my house, but 3 times.
All right, caught up? All right, so let's take a look at Try It 1 in our workbooks, page 128. Compare the measures of the labeled angle and side lengths for the triangles. All right, so here's an acute triangle, here's an obtuse triangle, and here's a right triangle. Now, in your books, they had K, K, and K, didn't they? Here, like this was length in your books says length K, length K, length K, doesn't it? Okay, so why don't you change the M? I'm gonna just change it right here. Okay, so I'll change it right there. So, is there something wrong? Are you sure? Okay, let's pay attention. So I want you guys to write down something that compares the measures of that side length K for each triangle. Write down something in your own words. Oh, in fact, I think there's something else here. This, it says J2, doesn't, that's J, and this is J. There we go. J, J, J.
No words spoken. So as
All right, Cassie, what's going on here? What happens with the length of K compared to angle J? Yeah. So in this case, if I want to write this down in more, in like a smidge more wordy, but has good information, I would state that the measure of angle J and the length of K both increase as the triangle goes from acute to right to obtuse. Okay, so the other thing I want to point out here is that if you guys look, we have a congruent, each part has a congruent side. Yes. Yeah, that's a great way to think about it. K is a rubber band and it will adjust based on the angle of J. Very good. All right. So in this case, we have, if you guys look, we have this side length congruent and this side length congruent, and that has not changed with either triangle. So in order to find out the length that is adjusting, you need to find the angle that is between the two congruent parts. Okay? Questions on that? All right. Now, example 2, we are not going to use, so I want you to just cross out the wording, but keep the space so you can write down your theorems. Somebody fill in Evan, because I think I've already said this, haven't I? What am I posting tonight? Help him out.
Study guide if it's done, and then tomorrow we get the handouts.
Yeah. And what else did I say I was going to post? Yeah, an odd puzzle in case you need it. It might come back. I'm going to try just for Ortho Center, but I don't know if that's going to be possible. So I'm going to try to give you something else that will help. I got to look. All right. All right. So here is what you are now going to write down. So theorem 112 is called the hinge theorem. You're going to want to write down that, kind of split the space in example 2 up, because you have a couple things to write. If two sides of one triangle are congruent to two sides of another triangle and the included angles are not congruent, all right, big deal here, not congruent, then the longer third side is opposite the larger included angle. So in this case, I would draw the pictures as well because it contains these markings that you're going to need. If the measure of angle YWZ, so X, Y to W to X, is greater than the measure of C to A to B. C to A to B. So again, we're looking at this guy and this guy. I'm not saying that they're congruent. I'm just highlighting them. Then XY is going to be greater than BC. And we kind of already discussed that, right? As that, it's called the hinge theorem because it's like you're widening an angle. It's like a hinge. Okay. So as that hinge gets wider or that angle gets bigger, that side length has to get bigger. Yes. To prove it? Yeah, this one is very much the proofs in the pudding kind of a thing. We're not going to formally prove this. You're not going to have to necessarily use this one on necessarily a proof, but new curriculum, I got to double check that. Okay. Show of hands, who is still writing this down? Okay.
What kind of did you choose?
All right. Is he caught up? Okay. All right. Here is your next one. All right. So just like with any good theorem, there is also the converse of the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is opposite the longer third side. Okay. So in this case, what they're saying here is if EF is bigger than UV, so this is the larger of the two, this is the smaller. That means this is the larger angle, and this is our smaller angle. And we are going to apply the hinge theorem here and the converse in just a minute. Identification is going to be key. The algebra is easy, but it's the identification of which is the larger angle and larger side that is going to help. Okay. Yeah.
Like the angle itself looks like it's the same. The other one looks like it's zoomed.
You're talking about like angle D and angle T?
Yeah.
I wouldn't view it as like something that's zoomed in. I would view it as something that's opened up or more closed. See how like if you just take your fingers, Hero, I go like this is getting bigger. If I go like this, it gets smaller. That's what's happening. They're just saying that one angle is larger, or one side is larger because that angle opened wider. Does that make sense? Good question. Any other questions? Okay. Anybody still writing? Okie dokie. All right, let's move on. So we are skipping example 3, so you can cross out example 3. Okay, what are the possible values of x? So here's a note. There are no vertical angles here. So you cannot assume that these two are congruent because they're not vertical. And Cassie's like, you just ruined my day, Smith. All right, so don't assume you have vertical angles when you need to apply the hinge theorem. So here's what we're saying. We're saying since FG, gentlemen, thank you, FG is less than CD. So here is F to G is 14. C to D in this case is 18. So this is smaller, this is bigger. We also know that CD is less than AB. AB is 21. So in this case, AB is greater than CD, and that's greater than FG. So we need to find the angles based off of that. In this case, because AB is the longer side, this is the largest angle. This guy would be second, this guy would be third, okay? So when we set this up to solve, we have 36 is less than 2x minus 4, and it's greater than 60. Like I said, after this, you guys know how to do this. This is just straight algebra, right? It's the identification that takes a minute. Don't rush into identifying what's bigger and what's smaller. When you're done, though, in this case, x is going to be between 20 and 32. Questions on that? All right, let's take a look at number 4. So I'm going to work on letter A with you guys. So it says, what are the possible values of x for each diagram? All right, so if we look at this, we have a side length of 12 and we have a side length of 10, which means this is our larger angle. Okay. So in this case, I'm going to set this up the following way. I definitely have that 4x minus 18 is less than 54. Now, because this is less than, what we're going to do is we're trying to find that restriction on x, right? We know x can't go past what number? No. Can an angle has to be greater than what? 0. Always greater than 0. So we're going to kind of set it up like this. Okay. All right. Again, we're just going to add 18. This leaves us with 18 less than 4x, which is less than 72. And then we're going to divide everything by 4. So in this case, we're going to have 4.5 is less than x, which is less than 18. So x has to land between 4.5 and 18. Okay, for this next one, again, now this looks a little kind of weird, right? But if we look, here's our 21, here's our 16, which means that this guy right here is our larger angle. Since that's our larger angle, I'm going to set this up the following way. I'm going to have 3x plus 5 is greater than 32. We're not going to have a 0 here because the restriction is already, 0 is kind of already included, and the restriction is going beyond that anyway. Does that make sense? Yeah, so we can't really do anything with the 0 there. Does that make sense? Do you guys see the difference between these two? Okay, so now what I'm going to do is I'm going to subtract the 5. So I have 3x is greater than 27. I'm going to divide both sides by 3. So I get x is greater than 9. That's it. So x has to be greater than 9 here to work. We don't need to put the 0 on the other side because the middle part was bigger. Okay? Yeah, you can't really do much with it after that. Questions on that? Anything? Okay. Is anybody still writing this down? All right, so again, this is just, I'm hoping you guys already have this in your notes, so no worries there. I want you guys to do 5, 6, and 7 in your books on page 130. Give those 3 a shot.
Well, look at the angle.
Okay, that's
58. That means AB has to be bigger than BC. AB, BC, I don't know how to find
the
it.
angle is
But-
tiny. Oh, I got it. 180 minus 15. 48 plus 5.
In my head, guys. I haven't used the calculator for 2 minutes. So BC is big still. So if it goes CB, AB, BC. Yeah. Order the measurements. Oh. So. So I think PTU is the big.
The opposite side?
Oh no, it's PTU.
Is the big. And then SQT
Yeah,
is
it's the opposite side.
So,
For it would be
wait.
yeah. So SQT
eight.
And then, but it's not. And then the QSR is
QSR is the
Six.
second.
yeah, and the smallest.
That's
So it's PTU to QSR.
yeah. And yeah, that's
Stop that. Get out of here.
Hopefully, it's
I don't
That would be so fun.
it's like
There's only one question.
Dude, obviously kayak B is close to the dock. Only to the dock. Oh, the dock is there. The dock is there.
6 PTU QSR. That's
But it's still kayak B. We don't have the numbers in there. Like, I can't eyeball a kayak and go, that's a 45-degree angle from this line. It's 150 yards. But if you could, if I could, it would be pretty helpful, right? But I can't. And we still have to solve it. Or I could just eyeball it.
Well, I know, but yeah, that's the point. Now you know how to solve it in real life. When you're in kayak racing, you know it's gonna So we
No, not when you're in the kayak race. When you're standing above the kayak.
and you're betting on who's gonna win.
Yeah. But you bet before the race happens. So
I bet.
you bet on a kayak race before the race starts. You don't see who's winning. You go, yeah, now I'm gonna place my bets on who's winning.
I bet
they're
that
exactly
exactly.
It's B.
Show of hands, you're still working on 5 through 7. Okay. Give me a little bit more time.
Absolutely.
No.
No. Look at the the dock.
Oh,
The dock, not the one.
Yeah. Oh yeah.
It's the dock.
And the angle is smaller.
Yeah. Because
No.
no.
No, but he's right.
Oh, but I am.
It's number 5. Number 5.
You're not-
I don't know. I haven't really been. I mean, I
Oh, you know, he's gonna fly above the kayak to see what happens.
No, I'll just find a few cards. And I can use the and then you can see the triangle. Oh, no,
No, he's young Einstein. So
no,
no.
not an eyeball.
They'll do it in your
I'll just put it into a No, I'm not on the kayak. It's not two cards. It's into
raising the wall. If they're driving to Walmart, they're never gonna be able like that. And then you can just see which one is closer to Walmart on the straight line.
They're in the Walmart.
In the Walmart, if they're in the parking, if they're in the parking,
They're trying to crash into the wall. They're still on the straight line right near the Walmart. No, I'll put one over here. The Walmart's right here. The Walmart is one crash gonna be right here. Some crash gonna be right here.
All right. Let's go over 5, 6, and 7. Izzy, you have 5? I think you have a flip-flop, but yes. Should have been least to greatest, so it should have been CD, AB. Yeah, I think, like I said, you just kind of flip-flopped it. No big deal. Okay. How about 6? What's going on with 6? Izzy, you know that one too? Go ahead.
Angle PTU. Wait, is it
Yeah.
Okay, SQT, QSR, PTU.
Yes. Good job. Sorry, I was looking at the thing. Okay. All right, so SQT is less than QSR is less than PTU. I'm leaving out like the angle things so that this way we don't get totally confused. All right, someone tell me, kayak A or kayak B, which is it? Is you know that one too? It is not. It's kayak A. 50-50 shot, yeah. You don't even get odds like that in Vegas. Okay, let's take a look at this. So remember, right here is a linear pair. So this guy ends up being 1 130, right? And this one ends up being like what, 125? So kayak A.
But kayak B can turn quicker because it's angled more towards the dock. So you get there first.
135, thank you. Yeah, 135. Yeah, that's what I messed up with. Okay, I'm like, wait a minute. Oh, did I mean to do it? This is 135, thank you. That's why A would be closer. There you go. Questions on that? How we doing? All right, keep going on. And realize you have your homework. That is it. Those of you watching, have a great day.